limits. And this is all review, but I just want to make sure we look at it again. Oh, look, highest power's over there this time. If I'm looking at end behavior, as x goes to infinity, I look at highest powers. And reduce that. And so that means that my limit is -3. And I'll notice that you would notate it as a horizontal asymptote by writing y equals, not just the number. Okay, looking at this, e to the x is funny because e to the x gets large for positive x's. But if you have a negative exponent, then it goes to 0. So if I'm looking at x going to infinity, this is the ratio, and it's -1 for the limit. If I look at x going to negative infinity, these become small, and I'm looking at 3/2 instead. So you got to be careful with e to the x. It's not a polynomial. If I look at this, the limit goes to 0 if there's a higher exponent on the bottom. Looking at this, goes to positive infinity even if x is negative. So this one, on the other hand, this one does go to negative infinity. Okay, it would be positive infinity on the right. So looking at 2 plus, you can graph it and see what the asymptote looks like, but if you look at this, you're a little bit bigger than 2. Okay, 6/0, positive infinity. 0 plus, so infinity. On this side, we have 3x still going to 6, sorry. But if x is a bit more negative, less positive than 2, (6/(-0) is going to negative infinity. If x goes to infinity, if you're looking at the end behavior, we just look at the ratio of the highest powers. So 3 is my limit. Okay, so how do you have a horizontal asymptote equal to 0? I should say here infinity or negative infinity. If we want a number besides 0, for instance, the last problem we just did, for instance, you want to look at the highest exponent being equal, and then you look at the ratio of the highest coefficients. Okay. Oh, look, an oldie but a goodie. Let's just do one of these for old time's sake. What is f of x plus h? We've done that a billion times. Okay, so to save a little space, I'm going to just FOIL that out. Oh, sorry, 2xh. That's only f of x plus h. Don't forget you got to have the f of x also. And then anything that doesn't have an h should cancel. Look at that. The x squareds cancel. And 3x minus 3x cancels. I'm going to go ahead and factor the h out of the top. Don't forget the 3. Once you've factored and canceled, you can plug in, and you get the derivative. It's a miracle. Done that a zillion times. Okay, so let's just sketch a picture. These things, there's a lot of freedom that you have. As x goes to 0, you'll reach a height of 2. You can have the value there, or you can have the value not there. It doesn't really matter. Limit as x goes to negative infinity is 3. Oh, we need to get it back up to a height of 3. Level it off towards a height of 3 at the end. And then limit as x goes to positive infinity needs to be negative 3. Let's manage to get it to level off towards a height of negative 3 towards this end. There you go. Okay, we don't really care what happens in the middle. Let's see. What does this say? It says, as x approaches 0 from the left, we want to go up on the left side, and on the right side, apparently this one wants to go down. Terrible W. Okay, so up on the left side, down on from the right side, and limit as x approaches infinity being an eventual leveling off towards a height of negative 3. There you go. All right, now this one, unfortunately, the copy didn't look very good. It got faded. Okay, limit as x goes to infinity, the height is 2. Limit as x goes towards negative infinity, that height levels off towards a height of negative 2. Okay, as x goes to 3, we seem to be going up on both sides. And at 0, we seem to be going down on both sides. Just a little note. It's up on one side and down on the other side. Let me say it that way. So, for instance, on that previous problem, problem 3, problem 5, 4, oops, let's call this 6. Problem 5, it's approaching going up on the left side of the y-axis and down on the other side, so we'd have to say it doesn't exist. Okay, as we approach -2 from the right, looks like we're going to -infinity. Some asymptotes. Because it does that, we'll have to call -2 and other places where it's falling off the bottom of the universe and off the top of the universe. Those are my vertical asymptotes. Horizontal asymptote, on the right it was y equals 2, and on the left it was y equals -2. So a little last note is that polynomials can't have two different horizontal asymptotes, but other functions can.